Hello everyone, welcome to certificate course on reasoning and quantitative techniques. In this video, we are going to discuss a number series, what are the different types of number series and how to solve the different types of number series. And we are going to solve some of the problems on each types. So let us start. Number series, it is a sequence of numbers which are arranged in specific order according to a certain period or rule. So these series can be finite or infinite and are commonly encountered in mathematics, logic puzzles, aptitude tests, and various other applications. Understanding and identifying the underlying pattern or rule governing the series is key to solving problems related to number series. So here are the some common types of number series pattern. Arithmetic series. So in an arithmetic series, each term is obtained by adding or subtracting a constant value to the previous term. So here the difference between each consecutive terms will be constant for the series. For example, 2, 5, 8, 14, 11. So if you see, the difference between two consecutive terms is 3. So that is, the series is obtained by 2 to each of the terms. So 2 plus 3 is 5, 5 plus 3 is 8, like that. Geometric series. So here each term is obtained by multiplying or dividing the previous term by a constant ratio. So in this case, ratio between the two consecutive terms will be constant. For example, 3, 6, 12, 24, 48. So if you multiply 3 with the 2, you will get 6. 6 into 2, 12. 12 into 2, 24. So the ratio between two consecutive terms is 2 here. So this is an example of geometric series. Square series. Here each term will be a perfect square. Like for example, 1, 4, 9, 16, 25. Here 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square. So square of all the natural numbers. Cube series. So each term will be a perfect cube. Like 1, 8, 27. 1 is 1 cube, 8 is 2 cube, 27 is 3 cube, 64 is 4 cube. So perfect cube of all the natural numbers. Fibonacci series. So it is a series in which each term will be obtained by adding two preceding terms. For example, here 1, 1. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, like that. So each adding two consecutive continuous terms will get the third term. Prime number series. So here we will use only the prime numbers, the number which is divisible by only one and itself, like 2, 3, 5, 7, 11, 13, 79. It is a prime number series. So alternative series, the pattern alternative between two or more operations or sequences. For example, we have this 2, 4, 3, 5, 4, 6. So here if you see 2 plus 2 is 4, the next pattern is 4 minus 1 is 3. Again 3 plus 2 is 5, 5 minus 1 is 4. 4 plus 2 is 6. So next term according to the rule 6 minus 1 will be 5. Like it is an alternation between adding 2 and subtracting 1. So combining both series we get this. So combination series, multiple patterns are combined within the same series. For example, 2, 5, 10, 17, 26. In this case, it is adding consecutive odd numbers. For example, 2 plus 3 is 5. Then 5 plus 5 is 9, 10. Then 10 plus 7 is 17. 17 plus 9 is 26. So next number according to the rule 26 plus 11. So that will be 37. So these are the different types of number series. Now solving problems involving number series often requires a careful observations and analysis to discern the underlying pattern or the rule. So first you have to identify what is the rule in the number series. So then we will be able to identify the missing term or the next term. So once the pattern is identified, so it can be extended to predict the future term so that to complete the series. So various techniques such as algebraic manipulations, reference method, and trial and error, which can be employed depending upon the complexity of the series. So here are some of the rules by which we can solve, identify the pattern, like solve the number series. First step is to identify the pattern. So in solving a number series problem, so it is carefully observe the given sequence and try to identify the pattern or the rule governing it. So look for the relationship between the consecutive terms such as addition, subtraction, multiplication, division, or any other complex operation. So that is the first step, identify the pattern. Second step is check for arithmetic progression. So arithmetic progression means the difference between should be two consecutive terms should be constant. So if the series involves adding or subtracting a constant value to each term to obtain the next term, so it is called as arithmetic progression. Then use the formula for the nth term of arithmetic progression. That is a plus n minus 1 into common difference. Examine squares and cubes. So some number series involves the third one. Look for geometric progression. If the series involves multiplying or dividing each term by a constant ratio to obtain the next term, it is a geometric progression. So again, use the formula for the nth term of the geometric progression. So that will be a into r to the power n minus 1. So a is the first term, r will be the common ratio, and n will be the required number. Fourth step, examine squares and cubes. So some number series involves perfect squares or cubes as terms. So if you notice that each term is a square or a cube of some value, so try to identify the pattern. So in which these squares and cubes are used. Consider prime numbers. So in some series, each term may be a prime number. So if you recognize that the numbers are prime numbers, so try to find the pattern or the rule that generate these primes. Use differences. So compute the difference between consecutive terms in the series. If the difference itself forms a pattern, so it can help you to identify the underlying rule. For example, if the difference between the two consecutive terms are constant, so it suggests that it is an arithmetic progression. Next, trial and error. If you are unable to identify a special pattern immediately, so try different operations or combinations of operations on the terms to see if they yield a series with the recognizable pattern. Check for multiple patterns. Sometimes a series may involve not just single patterns, it may have a two or more patterns combined. So that will alternate or change after a certain number of terms. So be open to the possibility of complex pattern and try to identify all the patterns which are present. Use previous terms. In some cases, the pattern may involve using multiple previous terms to generate the next. Like in Fibonacci series, we add the previous two terms and get the third series, like that. So try to identify how previous terms are combined or manipulated to obtain the subsequent terms. Practice and familiarity. So regular practices with the various types of number series problems will improve your ability to recognize pattern and apply appropriate solving techniques more efficiently. So remember to remain patient and systematic when solving number series problems. Careful observations and analysis are key to identify the underlying pattern and arriving at the correct solution. So these are the important rules or techniques to solve different number series. So let us solve some of the questions on number series. First question. Okay, find what number would come in place of the question mark. The series is 2, then 5, then 12.5, question mark, 78.125, 195.3125. So here if you see the ratio between the first and second term, that is 2 and 5 is 2.5, second and third also 2.5, 5 and 12.5 is also 2.5. So here the series is obtained by multiplying. So 2 if you multiply with the 2.5, we get 5. So again, 5 if you multiply with the 2.5, you get 12.5. So if you multiply 12.5 with the 2.5, so that is 12.5 into 3.2.5 will be 31.25. Then again 31.25 into 2.5, you will get 78.125 and so on. So the answer in this place is 31.25. So the answer is 31.25. Next question. Given a series 50, 45, 40, 35 and 50. So here if you see, the difference between each term is 5. That is 50 minus 5 is 45. 45 minus 5 is 40. 40 minus 5 is 35. Then 35 minus 5. So finally 30 minus 5. So the answer is 25. So that is 25 will be the answer. So this is an arithmetic progression. Given a series minus 10, minus 8, minus 6, 40, 102, and what is the last term? Okay. Now, what is the difference between minus 8 and minus 8? Minus 10, minus 8. So if you add minus 10 plus 2 is minus 8. Minus 8 plus 14 is plus 6. Then 6 plus 34 is 40. Okay, then 40 plus 98. Okay, sorry, it is 62. 62 is 102. So now if you see, how do you get 2? 2 is 2 square minus 2. Okay, 4 minus 2. So then 14 is 4 square minus 2, 16 minus 2. And 34 is 66 square minus 2, 36 minus 2, so 6 square minus 2. And the 62 is 8 square minus 2 is 62. So the next number will be like it is a continuous even number squares. So 10 square minus 2. So 10 square minus 2 is 100 minus 2. So 98. So that means to 108 we have to add 98. So 108, 102 plus 102 plus 98. So that will be 200. So your answer is missing term is 200. Next question. Given a series 25, 49, 121, 169. So if you observe the pattern, so this 25 will be, okay, what is 25? It is a square number, right? So 25 will be is a 5 square, 49 is a 7 square, 121 is 11 square, so 169 is 13 square. So this is a continuous square of prime numbers. Okay. So the answer will be 17 square. Next prime number will be 17 square. So 17 square will be 289. So your answer is 289. Next question. Given the series 1, 30, 5, 26, 9, 22, 13, 18. So here, if you observe the numbers, it is like increasing, decreasing, increasing, decreasing. So this is only possible when we combine two series. So like for example, if you take 1 and 5. So 1 plus 4 is 5. Again 5 plus 4 is 9. So 9 plus 4 is 13. So as per this rule, 13 plus 4 will be 17. So missing number is 70. So you don't have to check the other pattern. So other series will be like 30 minus 4 is 26. Okay. So this series will be 30 minus 4, 26. 26 minus 4, 22. 22 minus 4, 18. So that is the second series. Next question. 4, 18. Then third number is missing. 100, 180, 294 and 448. So first you have to identify the pattern here. Now, okay, so 4 is nothing but 4 can be written as this is 2 cube minus 4. Okay, 2 cube minus 2 square because 2 cube is 8. So 8 minus 4 is 4. So here 18 is this is a 27 minus 9 or simply 3 cube minus 3. Okay, now 100. 100 is 5 cube minus 5 square. So this is 3 cube minus 3 square, sorry. So 5 cube minus 5 square, 125 minus 25. So 120, 180 is 6 cube 216 minus 36. So 194. This is a 7 cube minus 7 square, that is 289 minus 49. And this is 8 cube minus 8 square, that is 512 minus 64. So as per that rule, this missing number should be 4 cube minus 4 square. So 4 cube is 4 into 4 into 4, 64 minus 4 square is 16. So 64 minus 16 is 48. So your answer is 48. Next one, 11, 12, 15, 20, 27. So here if you observe the difference, 11, 11 plus, okay, 11 plus 1 is 12, 12 plus 3 is 15, 15 plus 5 is 20, so 20 plus 7 is 27. So these are 1, 3, 5, 7. So these are the prime numbers, not prime numbers, odd numbers. So the next number will be 27 plus 9. So 27 plus 9 will be 36. So answer is 36. Next one, 14, 25, 47, 91, 179 and the missing number. So this is, yeah. Now if you see the difference between 14 and 25. What is the difference between 14 and 25? It is 11. Okay, 25 minus 14 is 11. And 25 and 47, the difference is 22. And the difference between 47 and 91 is 44. And difference between 91 and 179 is 88. So that is 11. 11 into 2, 22. 22 into 4, 44. 2 is 44. 44 into 2, 88. So as per this, the next difference should be 88 into 2, that is 176. So your answer should be 179 plus 176. That will be 255. So your answer is, sorry, 355. That should be 355. So answer is option C, 355. Okay. Next question. 4, 6, 9, 14, 21 and next. Now let us see the difference here. Okay. What is the difference between 4 and 6? So 4 plus 2 is 6. 6 plus 3 is 9. 9 plus 5 is 14. 14 plus 7 is 21. Okay. So these are prime numbers. 2, 3, 5, 7. These are prime numbers. So as per that, the next prime number is 11. So 21 plus 11. So 21 plus 11 will be 30. Okay. So answer is 30. Next question. 3, 4, 7, 8, 11, 12, and two numbers are missing here. Okay, we have to find two consecutive numbers out of all these options. Now, what is the okay, ratio between difference between 3 and 4? It look like the number, this series is a combination of two alternative series. Like you see, the difference between 3 and 7. Okay? From 3 to 7, the difference is 3 plus 4 is 7. Then 7 plus 4 is 11. Okay? 11 plus 4 should be 15. So this number will be 15. Now the other series, 4 plus 4, okay, is 8. Then 8 plus 4 is 12. So next number, 12 plus 4 will be 60. So this number is 15 and this is 16. So the answers are 15 and 16. Find the number which is wrong in the given series, that is 2, 3, 12, 37, 86, 166 and 288. Now see what is the difference between 2 and 3. So difference between 2 and 3 is 1. So difference between 3 and 12 is 9. 12 and 37 will be 25. So if you observe, this is 1 square, 9 is 3 square, 25 is 5 square. So next number should be next square of odd number. So that will be 49. Okay, 86 minus 37 is 49. That is 7 square. So as per this rule, so difference between 86 and 166. Okay, the next should be 8 square. That is 9 square. That is 81. But what is actual difference between 166 and 86? So 166 and 86 will be 80. So it doesn't follow the rule. So that means this number is actually 166. It should be 167. Okay, this is not 166. So here the wrong item is 166. Next one. 81 is to 101. Now what is the rule between 81 and 101? And that should follow for the second. Okay, 121 is to what? Now what is the relation between 81 and 101? So we know that 81 is a 9 square, okay, and 101 is a 10 square plus 100 plus 1. Similarly, 121 means 11 square. So as per this, it is 9 plus 1 is 10. So 11 plus 1 will be 12 square plus 1. So 12 square is 144. So 144 plus 1 will be 145. So the next number will be 145. 11 is to 121, 15 is to what? So this is a direct question where we have square of the number, because 11 square, okay, square of 11 is 121. So this is the direct, what is the square of 15? So that will be 225. So the answer is 225. Next one, question number 14. 2, 4, 8, 10, 14. So now if you see the difference between 2 and 4. Okay, the difference between 2 and 4 is 2. Here 2 is a difference. 4 and 8 is 4. 8 and 10 is 2. Again 10 and 4 is 14. So we have alternately added 2, add 4, add 2, add 4. So next will be 14 plus 2, so that is 16. So the missing number is 16. So this is the alternative, adding 2 and adding 4. Next number ratio 1 is to 1, 8, 9, 64, etc. Okay, next question. Now we have to choose this. If you know that 1 is 1 square, 8 is 2 cube, okay, 9 is 3 square, 64 is 4 cube. So we have 1 square, 2 cube, 3 square, 4 cube. So next number should be 5 to the power 2. Should be a square number. So 5 power 2 is 25. So the correct option is 20. Correct option is 25. Find the missing term. 6, 11, 8, 18, 27. So what is the difference here? 6 plus 6 and 11. The difference is 5. 6 plus 11 is 5. Then 11 plus 7 is 18. 18 plus 9. So difference is continuous odd number. So next one should be 27 plus 11. So 27 plus 11 is 38. Correct answer is 38. Next question. 3, 3, 4.5, 9, and what is the next term? Now this doesn't look like a difference because 3 minus 3 is a 0. So we'll see what is the ratio. Okay. How do you get 3 from 3? Into 1 is 3. Now 3 and 4.5 is into 1.5. Now 4.5 is 9 is into 2. 4.5 into 2 is 9. So we have multiply by 1, multiply by 1.5, multiply by 2. It is constantly increasing the ratio. So next, as per this, multiply by 2.5. So we have to multiply 9 with 2.5. So 9 into 2.5 is 22.5. So your answer is 22.5. 360, 15, 5. Obviously, the difference is not constant here. So next you have to check for geometric progress. So what is the ratio between 300 and 60? How to get 60 from 300? So that is dividing by 5. 300 by 5 is 60. Then 60 by 4 is 15. Then 15 by 3 is 5. So we have dividing by 5, dividing by 4, dividing by 3. So next one will be 5 divided by 2. So 5 divided by 2 is 2.5. So this missing number is 2.5. 2.5 is the correct option. This is the correct option. Next question. 1, 7, 37, 187 and 937. Now how to get difference between 1 and 7 is 6 here. But how to get that? You can do what is it? Is 1 into 5 plus 2. Okay. So we have 1 into 5 plus 2. So 1 into 5, 5 plus 2 is 7. Then we have 7 into 5 is 35. So 35 plus 2 is 37. Similarly, 37 into 5 plus 2, that is 180 plus 2 is 180. 185 plus 2 is 187. Similarly, 187 into 5 is 935. 935 plus 2 is 937. So then the last number will be 937 into 5 plus 2. So 937 into 5 is 406.85. 406.85 plus 2. 406. 406.87 is the answer. Next question. 1, 5, 19, 81. What is the pattern here? 1 into, maybe 1 into 2 plus 3. Okay, 1 into 2, 2. 2 plus 3 is 5. Then 5 into 3 is 15. 15 plus 4 is 9. So into 3 plus 4. And again for 19. 19 into 4, 76. 76 plus 5 is 81. So this, then according to the rule, 81 into 5. So 81 into 5 will be 240. Sorry, 405. 405 plus 6. So that will be 405 plus 6. That is 411. The next number is 411. Okay. Okay, next we have 0, 1, 1, 2, 3, 5, 8. So the options are given. So here this series is called Fibonacci series or Fibonacci sequence. So adding the first two term, we'll get third one. If you see, 0 plus 1 is 1. Okay. So 1 plus 2 is 3. Then 2 plus 3 is 5. 3 plus 5 is 8. 8 plus 5. So 8 plus 5 will be 13. So your answer is 13 is the answer. Next question. 3, 4, 7, 8, 12, 13 and what? Now let us see the difference here. Okay, the difference between 3 and 4. So how to get 3 plus 1 is 4. 4 plus 3 is 7. 7 plus 1 is 8. 8 plus 4 is 12. 12 plus 1 is 13. So we have alternatively adding 1 plus 3, adding 1 plus 4, adding 1. So this should be plus 5. So 13 plus 5 equal to 18. The next number is 18. Okay. So these are the some examples which we solved on different types. I hope you enjoyed this session. We'll see you again in the next video.